Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, dear students. Today, inshallah, we are talking about a very important part in physics in general, which talks about motion graphs. If we understand motion graphs, this means we will understand most of the graphs in physics, not only in motion. Let's start. For example, here, if I have these graphs, can we describe the motion according to these graphs? We have here two other graphs. They seem to be similar, but do they describe the same motion? All of these things we will learn today, inshallah. So be aware. Look at this graph. This graph describes the relation between distance and time. And this graph is called distance-time graph. Can we describe this graph, or can we describe the motion represented by this graph? Of course, yes. But firstly, we have to look at this. We have here two axes. We have here the horizontal axis, which is time, x-axis, and we have here the y-axis, or the vertical axis, which here represents the distance. And the most important axis here is the distance. We'll see here how the distance changes as time changes. Look at this. As time changes, what happens to the distance? Does it increase, decrease, or what? For example, here, if I say that the distance is in meters, and this point here is 20 meters. After 1 second, for example, the time is in seconds. After 1 second, what is the distance? 20 meters. After 2 seconds, the distance is 20 meters. After 3 seconds, the distance is 20 meters. So as time passes, the distance remains the same. This means the object here So this graph represents an object which is stationary object, or an object at rest. Okay. Now again, we have here the distance doesn't change as time passes. This means the object is at rest. Okay, look at this one. What is on y-axis? It is distance. What is on x-axis? It's time. As time passes here, what happens to the distance? The distance increases. For example, here after 1 second, the distance is, for example, 5 meters. After 2 seconds, the distance changes, and so on. This means the object is moving. When the object is moving, this means its speed has a magnitude, has a value. This value, is it constant or varying? As long as you remember here, speed equals distance over time. So the speed represents the ratio between distance and time. I have here this straight line, means that the ratio between distance and time is always the same. This means the speed here is constant speed. So this graph, as long as, again, we have here a straight line between the distance and time, this means the object is moving at a constant speed because this is a straight line. So this graph represents here a constant speed. Understood? Good. What if the line is no longer a straight line, like here? This means, again, the ratio between distance and time is not always the same. Look at this. It is not a straight line. This means the distance changes in different values when the time changes at equal values. For example, every second here, the distance changes with different values. The same thing here in, for example, if we say that this is graph C and this is graph D, in graph C and graph D, the distance changes irregularly with the time. Speed equals distance over time. But the graph is no longer a straight line. This means the speed is no longer constant. The speed here changes. The speed changes. What does this remind you of? This reminds you of when the speed changes, acceleration exists. So when the speed changes, acceleration exists. So we have here acceleration. We have here acceleration. This acceleration, as we remember, the acceleration can be either positive acceleration when the speed increases, and we have the negative acceleration when the speed decreases, and this is called deceleration. So look here. In the beginning of the time here, the distance increases, but not as big as when at the end of time here. Look at this one. In this time, the distance changes greatly. Look here, the distance doesn't change as big as at the end of the time. This means what? This means the ratio increases between distance and time. This means the speed increases. So we have here small speed, or we have here the object is slower and the object here is faster. This means we have here acceleration. So the object in this case is accelerating. What about graph D? Look here. In the beginning, as time changes, the distance changes larger than at the end of the time. Okay, this means what? This means the ratio here is greater than the ratio at this point 1 is greater than at point 2. What does this mean? This means we start with a higher speed and we end with a lower speed, or the object becomes slower. So the speed here decreases. Decreases, this means the object is decelerating. So if we have a distance time graph and we don't have a straight line, we have a curved line, this means we have a changing speed. Changing speed means acceleration. It can be positive acceleration when the object is accelerating, and it can be a negative acceleration or deceleration when the object decelerates or when the speed decreases. Understood? Great. Look here. I have here this graph. It's distance time graph. And we have two objects, object X and object Y. Which object is faster according to the graph? Which object is faster, X or Y? And why? Okay, very good. We see interval of time and we see which one covers longer distance. Again, we see or we determine which one covers longer distance in the same time interval. Let's see. For example, here, well, take this point here, okay, to represent a specific time interval here. And we see which one covers a longer distance. Look at object Y. It covers this distance. And what about object X? It covers this distance. Which one covers a longer distance? Look at this. Y covers only this distance and X covers all this distance in the same time interval. Which one covers a longer distance? X. So X is faster than Y because it covers longer distance in the same time interval. Great. We will see another way to get which one is faster after a while, inshallah. Look here at this graph and try to determine in which segment. I have here segment AB, another segment BC, another one CD and DE. Which segment represents a stationary object and which one represents or shows the highest speed and which one represents the lowest speed? CD. CD. Does the distance increase? No. Does it decrease with time? No. So the object here does not move. This means the object here is stationary object. Okay, this is the first one. What about which one has the highest speed? Again, to see the highest speed, here we will see, or we will determine which one covers longer distance in the same time interval. For For example, here, I have here the time in seconds. I will choose 1 second. This 1 second here in segment AB, the object covers 1 meter. We'll choose segment BC in 1 second between 3 and 4. The object covers half a meter from here to here, half a meter. And segment DC, in this 1 second, the object moves from this point to this point, so it covers 2 meters, from 4 meters to 6 meters. So which one covers longer distance? Here 1, here half, here 2. So in this segment, the object is the fastest. Okay, in which segment the object is the slowest or has the lowest speed? Again, we'll see. This one covers 1 meter in 1 second. This one in 1 second, it covers only half a meter. And this one here in DE, it covers 2 meters. So the slowest one means it covers the shortest distance in the same time interval. So we have here this segment represents the slowest, or the speed here is the lowest. Good. Okay, can we calculate the speed using the graph? Like here, I have here distance time graph. Can we calculate the speed from this graph? Yes, of course, we can. Why? Because the speed is a relation between distance and time. It equals distance divided by time. So if we divide this distance by this time, we can get the speed. But how can we divide it in the graph? Distance is on y-axis, as you remember. Time is on x-axis. To get the speed here, we have to divide distance by time. Distance is y, time is x. This means we are dividing y by x. This means we are getting the gradient. So the gradient here equals the speed. The gradient equals the speed. So we can get the gradient of this graph to get the speed. Good. But which part of this line we can use to get the gradient? Look here. We have distance, we have time. It is a straight line. This means we have a constant speed here. So the speed does not change during this time. What does this mean? This means we can choose any 2 points and we can get the speed in this graph. Because we have here a straight line, this means the speed is constant. This means we can use any part of the line to get the speed. For example, if I choose this point, for example here, I will get the gradient. You know how to get the gradient? The gradient equals rise, excellent, over run. Okay, where is the rise here? The rise is this line, which is vertical. It is from where to where? It is from 0 to 6. The rise, the gradient, as you know, equals rise over run. The rise is from 0 to 6, so we get the rise by subtracting these 2 values. Over, the run is from 0 to 3. Look at this, from 0 to 6, this is the rise. From 0 to 3, this is the run. So it is 3 minus 0. Get the final minus the initial here. So the gradient equals 6 over 3 equals 2. The distance is in meters. The time is in seconds. So it is 2 meters per second. Is it the same anywhere? Of course, yes. Look here. If we use these 2 values, for example, here, from this point and this point. Look at this, only this. This is the rise, and this is the run. Look here. This rises from where to where? From 8 to 10. So it equals 10 minus 8 over. This run is from where to where? From 4 to 5. From 4, the initial, to 5. So it is 5 minus 4 equals 10 minus 8 is 2 over 5 minus 4 is 1. So the gradient equals 2 meter per second. The gradient, as we said, it is the speed here. So the speed equals 2 meters per second. We have here a clearer one. The gradient equals rise over the run. Okay, the rise is the change in y-axis, or the change in the speed, or the distance, or the distance traveled divided by the run, which is the time taken to travel this distance. Okay, try to get this one again. I think we can get this. For example, here, can you calculate the speed in AB, in segment AB? Of course, yes. Look at this. Rise over run. The rise is from 0 to 3, and the run is from 0 to 3. So it is 3 minus 0 over 3 minus 0. So the speed here equals 1 meter per second. In this one, we'll change the color. In this one here, it is also rise over run. The rise is from 3 to 4. So it is 4 minus 3 over. The run is from 3 to 5. So it is 5 minus 3. It equals 3. 4 minus 3 is 1 over 5 minus 3 is 2. So it is half meter per second. What about CD? This is the run. Where is the rise? No rise. This means the rise is 0 divided by the run. So the speed here equals 0. So it is at rest or stationary object. Here in DE, the rise over the run. This is the rise, and this is the run. The rise is from 4 to 6. So it is 6 minus 4 over. The run is from 8 to 9. So it is 9 minus 8. So 6 minus 2 minus 4 is 2 over 9 minus 8 is 1. So the speed here equals 2 meter per second. In which segment the object is stationary? In CD. In which segment the object is the fastest? In DE. In which segment the speed is the lowest? In BC. Now it is, I think it is clearer. Look here again. Can you calculate this distance? Please, if you calculate it, please answer in the comment. This is the correct answer here. Look here. Can you answer this question? Read it and try to answer it. Here is the answer. Was your answer correct?